This is the completed counting circuit with all of the parts attached to this PCB board and this case encasing the entire board with a battery powered inside of it. We start off with this switch and this button. When the switch is flicked on and the button is pressed, the counting on the 7-segment display will begin to go up. However, there is a lot of backtracking to do before we get to talk about the 7-segment display and why it's counting up. We move back to the engine block compartment of the circuit, consisting of 2 capacitors, 4 resistors, a 4011 NAND gate chip, and a diode. These 2 capacitors decide the frequency and duration of the counting going up or down, depending on which way this switch is flicked, on the 7-segment display. This decides the frequency, and this decides the duration. Before the clock signals are passed on to the 4511 chip of the circuit, each of the input and output pins will receive a clock signal and it will continue on, thus creating this cycle of counting. If there was no clock signal and if there was no way to create a system of counting or an order of counting, this circuit would never work. The last impact that this 4510 chip has on the circuit before passing all of its outputs onto the next chip is creating value for this 4-bit binary system. Without value, this clock wouldn't be able to count. It could count up or it could count down, but it would never be able to display a certain number or a certain value to continue along with. Then, moved on to the 4511 chip. This 4511 chip is the direct connector to the 7-segment display, and it is the power of the 7-segment display. It takes the values from this chip and it converts them into actual numerical values rather than just digital ones. This 4511 chip is then directly connected to and powers this 7-segment display. The 7-segment display and each of its 7 segments are connected by these 2 banks of resistors, which not only help connect power to the segments, but also prevent blowing each of the segments, as keep in mind, these segments are all LEDs. Everything in the circuit that has led up to the 7-segment display so far has led to it counting up rather than counting down. However, as mentioned earlier, there does happen to be on this PCB an up-down switch which can control the direction of counting. When the switch is switched down, as the switch name would imply, the clock starts counting down. It is important to note that this circuit is only counting from 0 to 9, or 10 different units, despite the fact that it uses a 4-bit digital binary counting system. This is due to the fact that the chip used here is a 4510 chip, which limits the counting to 10 units, from 0 to 9. If a 4516 chip was used, the counting would go from 0 to 15, which or at least one singular 7-segment display cannot do on its own. If a second 7-segment display were to be added, the counting could go up to 99, but the counting would have to be more than 4 bits. It would have to be at least 8.